Hey folks, welcome back to section 7.3. This is the second video that I'm going to do, and I'm going to once again go a little bit out of order. So I'm going to skip example 1 temporarily. So if we go down to this box called the Cofunction Identities, I want to do this and then I'll work on example 2. I'll stop that video and then come back and start working with example number 1. So just a little bit out of order from what we normally do. Okay, so cofunction identities. These are already filled out. You may want to pause the video and go ahead and fill these out so that we can work the 3 small examples here. But basically what we're talking about here, this is something that we covered back in chapters 5 and 6 from the last section. And the way that I mentioned it in that section is I said cofunctions of complements are equal. And so you remember that complements are 2 angles that are added together to get 90 degrees, or if we were working in radians to get pi over 2. Cofunction, our cofunction pairs, sine and cosine are cofunctions, tangent and cotangent are cofunctions, and secant, cosecant are cofunctions. And so what we have here, this is basically a restatement of what we did earlier in the last section. And so we can say that the cosine of 90 minus theta, so there's that concept of complements. The cosine of 90 minus theta is equal to sine theta. You can say that with sine as well. You have the 2 pairs with tangent and cotangent, and then you also have the 2 pairs of secant and cosecant. But the main thing to know here is that cofunctions of complements are equal to each other. So then how do I put this into practice? So example number 2 is a pretty simple example. So it says find a value of theta or x. So typically thetas are used when we're working with degrees. X's and Y's are used when we're working with radians. Find a value of either theta or x that satisfies each of the following. So here we have secant of theta is equal to cosecant of 62 degrees. We know that secant and cosecant are cofunctions of each other. And we know our little statement says that cofunctions of complements are equal. So we just simply need the complement of 62. And so the complement of 62 is 28 degrees. And so that's our missing theta. If we jump over to part B, once again, tangent and cotangent are cofunctions. So that means that theta and negative 54 need to be complements of each other. And so we know that, and this isn't really a complement, honestly, idea. This is because of the fact that typically with complements, we're only dealing with positive angles. So this is where we get a little bit more in depth here than what we did in chapters 5 and 6. And where we have a tangent of 90 minus theta is equal to cotangent, or in this case, cotangent of 90 minus our theta is equal to tangent. So that's really what we're using here. All right, and then the last one, part C, again, sine and cosine are cofunctions of each other. So what is the complement of 7 pi over 6, or another way of saying that is what is pi over 2 minus 7 pi over 6? And so pi over 2 minus 7 pi over 6 is going to be a negative 4 pi over 6 because of the fact that you're thinking of pi over 2 as a 3 pi over 6, getting a common denominator there. So 3 pi over 6 minus 7 pi over 6 is negative 4 pi over 6. Of course, we wouldn't leave it like that. We're always going to reduce our fractions to negative 2 pi over 3. All right, so that's going to be the end of that video, just a small short video on cofunctions. Now let's go back. The next video is going to deal with the sum and difference of angles.